Have you ever looked up at the night sky and wondered what secrets the Milky Way holds? That dazzling band of light stretching across the heavens is more than just a pretty sight. It's our cosmic neighborhood, a barred spiral galaxy known as the Milky Way. As we delve into the mysteries of this galaxy, let's remember that we are part of it. We reside on a planet orbiting one of the countless stars that make up this galaxy. And here's a thought that might blow your mind. Our Milky Way is just one among billions of galaxies in the universe. We're part of a grand cosmic tapestry, woven with galaxies as threads. Now how about we talk size? The Milky Way is no small fry. It's home to between 100 and 400 billion stars. That's billions with a B. And that's not all. Interstellar dust and gas clouds are also part of the mix, adding depth and complexity to our galaxy's structure. These elements are the building blocks of stars, and they are scattered across the Milky Way, creating a celestial landscape of breathtaking beauty and diversity. But don't let the numbers intimidate you. Yes, the scale is immense, even mind-boggling. But it's also a testament to the incredible richness and variety of our universe. Each star, each dust cloud, each gas cloud tells a story. Together, they form the narrative of our galaxy, a narrative that scientists are still striving to understand. So, as we stand on our little blue planet, looking up at the night sky, let's remember this. We're just one tiny speck in this massive celestial city. Makes you feel small, doesn't it? But don't worry. Even as a speck, we have the power to explore, to learn, and to marvel at the mysteries of the Milky Way. Scene script. Have you ever pondered, what does the Milky Way look like from the outside? Well, let's embark on an imaginative journey to explore the structure of our cosmic home. Picture a gigantic spinning disk of stars, gas, and dust, spanning about 100,000 light-years across. This is the disk of the Milky Way, the main body of our galaxy, where the majority of its stars reside. Now visualize a dense, spherical region right in the center of this disk. This is the bulge, a concentrated area packed with older stars and interstellar matter. The bulge is like the heart of the Milky Way, throbbing with stellar activity. Encasing all this, like an enormous ghostly sphere, is the halo. It's less dense and filled mostly with old stars and clusters known as globular clusters. The halo extends far beyond the disk, as if our galaxy is encased in a giant bubble. But our galaxy is not just a bland, featureless disk. It's adorned with a stunning pattern, a spiral. These are the spiral arms of the Milky Way, like cosmic tendrils stretching out from the central bulge. They're not solid structures, but rather density waves, areas where stars and gas bunch up. And guess where we are in this grand cosmic design? Our solar system is nestled within one of these spiral arms, the Orion arm to be precise, about 26,000 light-years from the galactic center. But why does our galaxy have this beautiful spiral shape? It's because the Milky Way is spinning, like a gigantic cosmic carousel. This rotation, combined with gravity, causes the material in the disk to form these spiral patterns. So the next time you look up at the night sky, remember this. You're standing on a tiny planet, in a modest star system, located in one of the spiral arms of a flat, spinning galaxy. Imagine a cosmic merry-go-round with stars and planets whirling around a central point. Now isn't that a thrilling ride? Ever wondered what lies at the heart of our galaxy? Well, it's something so monumental, so extreme that it's almost impossible to comprehend. A supermassive black hole known as Sagittarius A*. Now, you may ask, what exactly is a black hole? In the simplest of terms, a black hole is a place in space where gravity pulls so much that even light can't escape. It's like an invisible cosmic drain, pulling in everything that dares to come close. Now let's take a moment to understand the scale of Sagittarius A is. But if black holes are invisible, how do we know it's there? Well, the evidence comes from watching the behavior of stars and gas clouds around it. They orbit at such high speeds that there must be something incredibly massive, yet invisible, pulling them in. And the only thing we know that fits this description is a black hole. Moreover, scientists have been able to capture a silhouette of Sagittarius A* using radio telescopes. This isn't a direct photograph, but it's the closest we've come to visualizing this behemoth. We're also beginning to understand the role that Sagittarius A* plays in our galaxy. It's not just a destructive force, but a creator as well. It influences the orbits of stars, shapes the structure of the Milky Way, and may even trigger the formation of new stars. So there you have it. At the heart of our galaxy is a supermassive black hole, a cosmic monster with the mass of millions of suns, influencing everything around it. A monstrous black hole, millions of times the mass of our sun, lurking at the center of our galaxy. Quite a neighborhood we live in. Is it just us? Or is there anyone else out there in the Milky Way? This question has fascinated humans for centuries, and we've been hunting for answers with a keen sense of curiosity and wonder. It's a quest that takes us into the realm of the unknown, into the vast expanse of the Milky Way, our cosmic home. Imagine our galaxy as a bustling city with over 200 billion stars, each potentially hosting its own planetary system. Just like our Earth orbits the Sun, these exoplanets orbit their respective stars. Some of these exoplanets, just maybe, are located in what we call the habitable zone, or the Goldilocks zone. This is the region around a star where conditions could be just right, not too hot, not too cold, for liquid water to exist on the surface of a planet. And where there's water, life as we know it could possibly thrive. We've already discovered thousands of these exoplanets thanks to missions like NASA's Kepler and the European Space Agency's Cheops. Some of these distant worlds have conditions that are strikingly similar to Earth. Take, for example, the planet Kepler 22b, which is located in the habitable zone of its star, and could potentially have a surface covered by a vast global ocean. But the search doesn't stop at finding potentially habitable planets. We're also listening out for signals that might indicate the presence of extraterrestrial intelligence. This is the mission of the Search for Extraterrestrial Intelligence, or SETI. Using advanced technologies, SETI scans the galaxy for signals that could indicate the existence of technologically advanced civilizations. Imagine the possibilities if we were to receive a signal. It would be a profound moment in human history, forever changing our understanding of our place in the cosmos. We may not know for sure if we're alone in the Milky Way, but the search continues and the possibilities are infinite. So, as we gaze up at the night sky, we are reminded that our quest for understanding is far from over. It's a journey of discovery that will continue to push the boundaries of our knowledge and imagination. What's in store for our galaxy in the distant future? As we journey through the cosmos, we're not just passengers on a solitary spaceship Earth, but part of a colossal cosmic community, the Milky Way galaxy. As we look ahead, the future of our galaxy proposes a grand spectacle, a cosmic ballet that unfolds over billions of years. Let's talk about the main event, the eventual collision and merger with our cosmic neighbor, the Andromeda galaxy. Now before you get alarmed, remember that this is in about 4 billion years, so you have plenty of time to finish your coffee and watch the rest of this video. The term collision might sound catastrophic, but it's a bit of a misnomer. When we think of collisions, we often picture a cataclysmic crash, a cosmic demolition derby. But that's not quite the case here. You see, the distance between stars, even within galaxies, is so vast that the likelihood of stars actually colliding is incredibly small. Instead, think of it as a graceful dance, where two galaxies drawn together by the irresistible pull of gravity begin to intermingle and intertwine, creating new patterns and structures in the cosmos. Over time, both galaxies will lose their distinctive spiral shapes and merge to form a larger elliptical galaxy. This cosmic dance won't be a quick waltz, but a slow, stately ballet that unfolds over hundreds of millions of years. It's a process of incredible beauty and complexity, a testament to the grandeur of the universe. The future of the Milky Way, therefore, is not one of destruction, but transformation. It's a future of change, of evolution, and of new beginnings. It's a future where our galaxy doesn't just exist, but actively participates in the grand cosmic ballet. A cosmic dance of epic proportions awaits our galaxy in the distant future. It's a spectacle we can only imagine,